everyone. In this part we are going to talk about the parallel arrays. So before getting into the subject, we need to know what are the parallel arrays. The parallel arrays are two or more than two arrays that contain related data. For example, one array contains the information about a student, while the other array contains the information about the subjects of that student or the grades of that subject. So we may have got multiple arrays that contains related data. So a subscript or an index is used to relate arrays in order to get elements from one array and the other array. We need to use the index or the subscript in order to make the relation between them or compare them, or showing some data based on their relationship. So we may have the arrays of different types. It's not compulsory that the arrays are of the must be the same of the same type, such as integer or character or string or whatever. So we may have an array which its type is integer and it is related to an array which its type is character or stuff like that. Here is an example of parallel array. For example, we've got a size of 5, int id of 5, double average of 5, char grade of 5. So we may say this is the ID of the student, and this one is the average mark of the student, and this one is going to be the grade, which it is in character type. So the ID is integer, and the double or the grade is the mark is double, and the grade, for example, if it's good, very good, excellent, medium, or fair, or fail, or whatever, is going to be in character. So those arrays are related to each other. This one is related to this one, while this one is related to the student. Okay, so we are opening a for loop for it. So we are printing the student ID, then the average of this student is going to be this average, this mark or this number, which is in double type, and the grade is going to be this one. So it creates a list for you, and it arranges 5 students: the first student, second one, third one, fourth one, fifth one, and the average and the grade of them is going to be in the same, is going to be shown in the same row. This is an example of the parallel arrays. And this one is another example of calculating the hours worked by 5 different employees, and the amount which they get in each hour, and finally it calculates the final amount which can be earned by each employee. So we've got 5 employees, and we are creating the array hours, which is the size of it is going to be 5, and the pay rate of each employee is going to be 5. Why? Because we've got 5 employees, and we may have 5 different hours and 5 different pay rates. So we are opening a for loop in order to go through the array. So the hour worked by the first employee, which is going to be index plus 1. So we will be with the numbers are starting from 1, but the indexes are starting from 0, or the manuscripts are starting from 0. So the first one is going to be this one. We are entering the number of hours which is worked by that employee, which its number is 1 and the index is 0, and then the pay rate for that employee is going to be this value, which is going to be stored in the first index, or the index in the, or the element in the index 0 in the pay rate array. So we are entering that one and that one. Then, and the loop, the loop is going to be iterating for 5 times, and then at the end we are going to calculate the gross pay, which is the amount which that employee is going to be earning. So the number of hours multiplying by the pay rate. So if he or she has worked for 5 hours and the pay rate is $5 per hour, so 5 multiplied by 5 is going to be 25. And then we are going to print in the employee number which is index plus 1, number 1, 2, 3, 4, 5, but the index we know starts from 0 up to 4, and printing the amount which that employee has earned. So for example, if we say 10 hours is worked by that employee, and the pay rate is going to be 9.75, so this one is going to be multiplied by this one, which is going to be 97.5, and this one multiplied by this one, that one multiplied by that one, and this is going to be the output. And this is how they are stored and they are related to each other. This is going to be the employee 1. The index 0 is going to be employee 1. It has worked for 10 hours and the pay rate is 9.75, so they are going to be multiplied by each other in order to calculate the final amount which that employee has earned. So this is going to be the employee 1. That's why we have said index plus 1. So this is going to be employee 2 index plus 1. It's going to be 2. This is these are the 5 different employees and their related data, the number of hours they've worked and the pay rate of each of them. How to pass an array to a function, or how the functions are working with the arrays. In order to apply a function to an array, we just write down the name of the array. So if this test is an array, when we are applying that function, so shows cause of that array, we just mention the name of the array. But in order to define the prototype, we need to just write down empty brackets of integer type. In the function header, we need to write down the parameter as well. So these are 3 main different things which you can relate or make a relation between the arrays and the functions. And sometimes you may write down the size of the array when you are calling a function to be applied on that array, so that the function knows how many elements are going to be processed. So but in the function header, we need to write down the size of the array, which is going to be this array, and the size is going to be this one. And even in the function header, we need to write down we know that we need to write down the parameter name, and even we need to write down the size of that array which this function is going to process it. This is an example which demonstrates an array being passed to a function. We are applying a function on an array. For example, void show values on an array. So this is the function prototype. It's not the function header. That means this function is going to be applied on an array of this size. Look, what do we have in there? Example. You've got the size of 8. That means we've got 8 elements in that array, which we are going to define later. The array name is numbers and the size is going to be 8, and we've initialized that array and we've given 8 different parameters to that array. Okay, and then we are calling this function. When we are calling that function, we need to mention the array name, which is the numbers and the size of it, and return 0. Let's see what is going to happen inside that function. So in the function header, we need to write down the parameter name or the array name. We know that we can give different names in the function header. While the name of the array is numbers, but we are mentioning nums here, so it's alright if you have written a different name here. And we need to pass the size as well. And we are going to throw the array one by one from index 0 up to index 7. Why? Because the size is 8, and if the size is 8, that means we've got 8 parameters starting from index 0 up to 7, and we are printing each element from 0 up to 7, and this is what the program gives you in the output. And two-dimensional arrays, the two-dimensional arrays is one of the most important subjects in programming. So two-dimensional arrays can be defined to one array for multiple sets of data. That means in single-dimensional arrays or normal arrays, we've got only rows, while in two-dimensional arrays we've got rows and columns, like a table in a spreadsheet, or we need to have two sizes instead or only having one size. For example, in the normal arrays we've got only one size in order to declare the number of elements in that array, but in the two-dimensional arrays we've got two sizes, which are rows and columns. The first one is identifying or defining or specifying the number of the rows, while the second one is the number of the columns. Okay, so this is very important. That means this table array or this matrix or this two-dimensional array is consisting of 4 rows and 3 columns. Look at here, we've got constant int rows 4 and cols 3, and int exam, this is the name of the two-dimensional arrays, and this is the size of the rows, and this is the size of the columns. That means we've got 4 rows and 3 columns. 1 2 3 4. That means 1 2 3 4 rows and 1 2 3 columns. And how to call each index or each subscript? The first one, we are starting from the first one. This is going to be the row 0, row 0, row 0, row 1, row 1, row 1, row 2, 2, 2, and row 3, row 3, row 3. This is going to be the first column, or the column in index 0, second column and third column. So this is the column 0 0 0 0 1 1 1 1 2 2 2 2 in index. So if we specify the first element is going to be in the row 0 and column 0. If we specify this element in the row 2, this is row 0 1 2, and the column 1. Why? Because this is column 0 and this one is column 1. This one 3 2. That means in row 3 and column 2, and we know that the indexes are starting from 0. So in order to access each element, we need to specify the index of the row and the column as well. For example, if we access this element 2 2, that means this one, this index, we need to specify the row index and the column index, and then we can give it a value or prompting from the screen or printing it or whatever. In this case, we've initialized or we've given this value to that index, which is this one. So this one is going to be 86. This is very important. These are the basics of the two-dimensional arrays. Look, in this program you are demonstrating a two-dimensional array in an example. Look, number of divisions is 3, number of quarters is 4. Okay, so that means when we are defining this array of sales in type double, the number of the rows is going to be 3 and the number of columns is going to be 4, and we are calculating the total sale, which sums up every parameter in that two-dimensional array. So we are defining those two variables and we are prompting those things from the screen. And look, the total sale is going to be 0 at the beginning. Look, we need to add every single element to that total sale. In order to access all the elements of each two-dimensional array, we need to use a nested loop. And the first loop indicates accessing the rows, while the second one indicates accessing the columns. Okay, so the rows are starting from 0 up to less than the size, and the columns are starting from 0 up to less than the size. So directly after opening the row loop, we need to open the column loop, and then the division of 1, so that means starting from 0 plus 1 is going to be 1, and the quarter of 0 plus 1 is going to be 1, going to be this value. We are accessing through this one, and we are giving it a data. We are entering a data to that parameter, which is going to be the index of rows 0 and the column 0, and then this one is going to be 1. This one remains 0 up to this one, iterates one time, then it goes to the outer loop to iterate the second one, and then this one is going to be iterates for three times, four times, three times, yeah. Then it goes back again. So we need to specify the inner loop and inner outer loop first, and then the inner loop. Then we can enter all the values of that two-dimensional array, which is going to be 3 rows and 4 columns. And then in order to print it, so we have inters, and then in order to calculate the total sale, we need to calculate every single element added together into the total sale. So we are opening another loop just like we did before, and then another loop for the columns. Then the total sale was 0 equals the total sale, which was 0, plus this element, which is row 0 and column 0. Then the column is going to be 1, then 2, then 3. So all of them are going to be added together, and then we are going to print the total sale at the end. This is the output of the program. At the first time it shows you division 1 quarter 1, and you are entering a value, and then division 1 quarter 2, division 1 quarter 3, division 1 quarter 4, and then for the second row, and then for the third row, and column 1, 2, 3, 4. So that means in a 3 by 4 two-dimensional array, we've got 3 multiplied by 4, 12 different elements. That's why we have entered 12 different values, and then we are going to calculate the total of them, which is going to be this value. Okay, in order to initialize a two-dimensional array, we need to initialize them row by row. For example, rows 2 and columns 2, specifying rows and columns equals 2. We need to open that bracket and close it at the end in order to specify the array, and each row must be between 2 curly brackets. So this is going to be the element row 0 column 0, row 0 column 1, then closing the bracket, then comma for the second row. This is row 1 column 0, row 1 column 1. So this is how you can initialize a two-dimensional array. Okay, and this is the best way to initialize a two-dimensional array. And this is very important, how to pass a two-dimensional array as a parameter argument to a function. I'm going to come back to the function call later, but for the header, we need to specify the column. For example, we are defining this function in the header, in the header, this one, where let's say prototype at the beginning. We need to specify that function is going to process a multi-dimensional array. This is going to be the rows, and this is going to be the columns. Okay, and then we need to specify the size is integer, but we need to write down the calls as well. Okay, the size of the columns, while it's a variable or it's a hard code number. Then in the header also we need to specify the calls, and the size is going to be, for example, rows or whatever. Even in the calling function we need to specify the calls, so this value refers to the calls, rows. Look, in this example we have a function and we are showing an array. Okay, so we say in the function header int, the name of the array is array, and specifying that is a two-dimensional array, and we need to specify the column size, and then in the size we are going to specify the rows. This is very important. We need to identify this shape whenever you are writing a program two-dimensional array. So x equals to 0 in order to start in the rows from 0 index, and while is less than the number of the rows, and 1 by 1, increment 1 by 1, and then for the calls as well. Then this we are going to print out each array from row 0 and call 0, and then it's going to be incremented 1 by 1. First time calls are going to be incremented, then it goes to the second row, and then when we're done doing that, we are going to going to the next line, and we are going to close the brackets. And set with is a function. We are going to talk about it later, and just ignore it for now. And this slide is telling you how to call a function to be applied on a multi-dimensional array. For example, if we've got table 1 rows calls equals to those values, table 2 rows and calls equals to that value, and then we are going to call the array the function or to be applied on that array, which is table 1, and then we are specifying the size of the rows, and then for the table 2 as well we are specifying the size of the rows. But in the function header we need to specify this call size, which we don't have it here. We have in the previous slide here. We need to specify the parameter in the array argument in the header of the function, and how to sum all the elements in a two-dimensional array. Look, this example is going to clarify everything. We've got 5 rows and calls, and the total is going to be 0 at the beginning, and the array name is going to be numbers 5 and 5. That means the number of the rows is 5 and the number of the calls is 5. So that means 1 2 3 4 5 1 2 3 4 5 5 rows and 5 calls, and we are going to add all those values together. So at the beginning we have that total was 0, and then we are opening a loop for the rows and a loop for the calls, and then total equals to total plus each index, and we know that the index are starting from row 0 and call 0 and adding to the total value. Then the call is going to be 1, row 0 call 1 is going to be added, 2 row 0 call 2 is going to be added, 3 row 0 call 3 is going to be added, 4 row 0 call 4 is going to be added, and it's going to be 5 is not less than 5, so this loop stops. It comes back to this loop. The row is becoming 1, and 1 is less than 5, yes, and then this loop is going to be iterating for 5 times. Then all the 5 different other elements are going to be added to the total in the second iteration of the outer loop. So each time this loop is iterating once, this one is going to be iterating 5 times. This is how a nested loop is working. So at the end, when we are done calculating the total, we are going to display the total. In this example we are going to show how to sum only the rows of a two-dimensional array. So far in the previous example we have summed or we have added all the elements in the two-dimensional array, but in this case we are going to add only the rows. For example, this one plus this one, this one and this one and this one in the first row, or in the second row, or in the third row. So we have defined an array of the number of the rows is going to be 3 and the number of the columns are going to be 5, and then let's see what we are going to do. We are going to open a loop for the rows, so the rows are starting from 0 up to less than the number of the rows, and we know that y, and then the total is 0. So how to sum a row? We are going to open a loop for the columns. Okay, why? Because each row, this row is consisting of 5 columns, 1 2 3 4 5. So we have opened the loop for the rows and we are in the first row now. So we are going to calculate the columns of that row together, because in order to add all the values in one row we need to add the calls value, the columns values. Then we are going to open a loop for the columns starting from 0 up to less than 5, so that means index 0 up to index 5, and total equals to total plus row 0 call 0, which is going to be this value. And then what happens? The loop is going to be starting again. Why? Because if we don't open brackets for a loop, that means only the first statement after loop is going to be executed. After that the loop is going to be back to check the conditions. So the calls is going to be 1, 1 is less than 5, yes, it adds row 0 col 1 to the total. Col is becoming 2, 2 is less than 5, yes, it adds the row 0 col 2 to the total. Then col is becoming 3, yes, 3 is less than 5, it adds row 0 col 3 to the total. Col is becoming 4, 4 is less than 5, yes, it adds scores of 0 and 4, that means row 0 col 4 to the total. Then col becoming 5, 5 is less than 5, no, so the loop stops. That means we've added all the values in the first row to the total. Then it comes here, it calculates the average equals to the total divided by the number of the scores, which is 5, and then we are displaying the average, which is going to be the student number. 0 plus 1 is going to be the student number. 1 is this value, which is the average. So that means if we don't open curly brackets for a for loop or for any other loop or an if condition or whatever, only the first statement is going to be executed based on that condition happening, and then the loop is going to be checked again. Based on the previous example, if you want to sum only the columns of a two-dimensional array, so instead of starting the rows first, we are going to start the columns first. Okay, for the first columns, the rows are going to be calculated. So this one iterates one time, while this one is going to be iterated based on the number of the rows, which is going to be 3. Okay, so for the col 3, all the rows are going to be calculated 3, so they are 3 rows. So the col is 0 and the row is starting from 0. 0 is less than 3, yes, so the row 0 col 0 is going to be added to the total. Then the row is becoming 1, row 1 col 0 is going to be added to the total. Row 2 col 0 is going to be added to the total. Row is becoming row is becoming 3, 3 is not less than 3, and this loop stops, and then the average is going to be calculated and it's going to be displayed. So this is how you can sum a row of a two-dimensional array or a column of a two-dimensional array, and how to use multi-dimensional arrays to hold string values. For example, we've got constant int names equals to 3, size equals to 10. That means we can use those two values in order to define a two-dimensional array of a string. Or so we can say char students names size. That means this is going to be the number of the rows or the number of the elements in that two-dimensional array. This is going to be a two-dimensional array of a string. Okay, and that means we've got 3 different elements, and this is going to be the size of each different element. So the maximum size, so the size of this one is 3, the size of this one is 4, the size of this one is 5. So that means the maximum size of each element should not exceed or must not exceed 10. Okay, so 5 is okay, 4 is okay, 3 is okay. So you can use only rows in order to reference any string in a two-dimensional array. This is row 0, row 1, row 2. So this is an example. It must clarify everything. So the number of the months is 12, the string size is 10. That means each element in that array which we are going to define for a character, which is months, should not exceed 10 characters. So number of months, that means we've got number of months values, which is going to be 12 values, and the string size, which is going to be 10. So each string here must not exceed 10 characters. So 1, 2, 3, 4 up to 12. We've got 12 different elements up to the number of months, and this one specifies the size of each string. So then we've got another array which is one-dimensional array, int days, number of months. We've got 12 different values. So each, you know that each value here, each element here is going to specify the number of the days included in each month. So then we are printing months of count. For example, the count starting from 0, which is going to be this one, has days of count, which is going to be this one. Days of months of 0 is going to be January. Days of 0 is going to be 31. Then count is going to be 1. Months of 1, which is going to be February, and days of 1, which is going to be 28. So that means February has 28 days. This is how you can use a character in two-dimensional array, and this is going to be the output of the program. And then finally, even we can use three or more dimensional array. Then we need to specify x, y, and z, the x, y, and z, the dimensions of the array. This is going to be x and y, and 4 dimensions and whatever we've got. And then we need to specify at least 2 different size of the dimensional array, or 3 dimensional arrays, or in the fourth we need to specify